Morning 5B. This is Mr. Wong. Today is 15th of April, Wednesday. Alright, we'll be going through the answers for yesterday's homework, which is page 6 and 7 of your electrical system SIN, followed by activity 5.1, which is also your homework. And then today we'll start on open and closed circuit. What is an open circuit? What is a closed circuit? Alright, so let's start with the homework first. We have talked about batteries and wires, so today we'll be talking about switch and battery. Alright, so switch, what's a switch for in an electric circuit? A switch is used to open or close an electric circuit. Okay, like the switches you have on your wall at home. If you want to turn on the light, you have to on the switch, you have to turn off the light, you have to off your switch. So the switch acts like a control, okay, to open the circuit or to close the circuit, which you will learn later for the lesson today. Okay, so when a switch is open, let's highlight this. So when the switch is open, there is actually a gap in the electric circuit. Okay, later on you will see the gap in the lesson for today, which is open and close circuit. And after the lesson, I will give you the link to the electric circuit simulation online, so you can play around with the circuit constructor, so that you can appreciate better what gap are we talking about here. So when a switch is open, there's a gap in the circuit. Electric current cannot flow through the gap. Okay, so if there's a gap, the electric current cannot flow through the gap, and that's why we call it a open circuit. Okay, sorry, this is supposed to be here. So electric current cannot flow through the gap. Alright, so if the circuit is open, there's a gap, and electric current cannot flow through the gap. Okay, and on the other hand, let's use a different color. If the switch is closed, there is no gap. There's no gap because the switch is closed, everything flows continuously, there's no gap, and in this case, electric current can flow through the electric circuit. Alright, so there are two types of circuit which you will learn today, open and closed. Open circuit means there's a gap. Closed circuit means there's no gap, and the electric current can flow, and that's why our light bulb would light up. Right, so let's go to the bottom. Now we talk about bulb. This is how a bulb looks like. Most of you can see, with a magnifying glass, you can see this part of the light bulb, but most of you can't see what's inside, and most of you will not realize why you have to connect one wire to the metal casing and one wire to the metal tip in order for the light bulb to light up. So if you explore deeper, if you can see the inner workings of the light bulb, you realize that the filament here, which gives off your light and heat later, is actually connected to two different wires that ends up in two different places. One side of the wire will go to the metal tip, the other side of the wire will go to the metal casing. Alright, so if you connect two wires to the metal casing, it will not light up because it means that this wire will not be connected to the circuit. It will be an open circuit. If you connect two wires to the metal tip, again this one will not be connected to the circuit. It will be an open circuit. Therefore, in order to make a bulb light up, one of the wires must be connected to the metal casing, the other wire must be connected to the metal tip. Okay, we'll explore this later in the lessons to come. Okay, so let's look at the different parts of a bulb. The glass bulb, what is the glass bulb for? The glass bulb is actually allows light to pass through because it is clear, it is transparent. Okay, so light bulb allows light to pass through. Okay, leaving of glass because of two reasons. One is clear, light can pass through. Another reason because it can withstand high temperatures. If I use a plastic cover to cover the top, which is this part, you realize that at high temperatures the plastic may melt. Okay, so that's why plastic is not used usually. Usually we'll use a glass because glass is, besides being transparent, allows light to pass through. It also is resistant to heat because the filament will also give off heat and light at the same time. Okay, wires on the other hand is quite straightforward. Wires allow the electricity to pass through. allows the electric current to pass through. Okay. All right. Okay. Maybe I can make it fit. All right. Something like that. Okay. So the wire actually allows the electric current to pass through. In other words, it means it allows. In other words, it means that the wire conducts electricity. Okay. Right. So wires is a function of the wire, which is the same for other parts of the circuit as well. Wires are there to allow the electric current to pass through, which also means it conducts electricity. Okay. After that, we have our metal casing and our metal tip. Whereas casing is at the side, tip is at the bottom. So what must happen here is that a wire must be connected here. Same thing for the metal tip. Okay. So the light bulb must be connected to the circuit through two places. One is the casing, one is the tip. So same thing for the tip. Right. Like what I said just now, in order for the light bulb to light up, you must connect the bulb to the metal casing. One wire must be connected to the metal casing, another wire must be connected to the metal tip in order for the light bulb to light up, because you realize there are two wires, one goes to the tip, one goes to the casing. Alright, maybe I should highlight so you can see what I'm talking about. Okay, so talk about this. One to the tip, which is a different color, and the other one actually goes to the casing. Right, so the last part, filament. Filament is the one that produces light and heat when electric current passes through it. So that's the function of the filament. Right, so sometimes we say the bulb fuse, the bulb blow when there's too much electricity flowing through it. What we mean is that the filament actually melts or actually burns out. Okay, so when you supply too much electricity through the filament, when for example a lightning strike and then there's a power surge in your house and then you're using a filament light bulb, the amount of electricity that passes through the filament at that point of time may be too much. It causes the filament to melt or to burn out, and that's what we call the bulb to be fused. Right, so this is page 6. Let's go on to page 7. Okay, page 7 is to mainly to get you to think about uh, the uses of electricity and how electricity actually comes from in Singapore when we use it. So the first question is where does electricity come from? For those who basically if you look at the industrial area, sometimes you see the tall chimneys. So those are indication that there might be power plants. So what happens that electricity is actually generated from power plants, and we'll talk about how electricity is being generated. All right. So electricity is generated from power plants, and how do power plants generate electricity? They generate it by burning fossil fuel. Can be natural gas, can be oil, can be coal. And when they burn the fossil fuel, they actually produce steam, because as they burn they will heat up the water becomes changes state to produce steam, and then the steam will go on and turn the turbines, and when the turbines turn, the electricity will be generated. Right. Okay, we will make it bigger so we can see. Right. So where does electricity come from? In Singapore, basically generated from power plants. How they do it? They burn fossil fuel like natural gas, predominantly in Singapore, to produce steam. So when they burn the fossil fuel, the water is heated up, becomes steam. Steam rises, turns the turbines, and generate electricity. I'll probably put in a few videos on this in the lesson so you have a better idea on what we are talking about, on how electricity is being produced. So the second question is, why do we need to generate electricity? Very simple reason, because you realize that we burn fossil fuel to generate electricity. So it's important for us to conserve also the amount of fossil fuel that we burn. And why must we conserve the amount of fossil fuel? Because it is a limited natural resource. Right. So we need to conserve electricity. Of course, main reason is to save money. But besides that, it's really to conserve the amount of fossil fuel, which is a natural resource and is limited. Okay, one day we'll use them up. Okay, they don't get regenerated as fast as the rate at we use fossil fuel. So part C is quite straightforward. Name some appliances that uses electricity. Almost everything you use that you have around you uses electricity. The fact that you're doing HBL, you're using a computer, so your computers are the ones using electricity. So for example, the phone you have, the mobile phone, uses electricity. Okay, and of course things like your TV and things like aircon, they use electricity as well. Right, so there are many ones. You don't have to follow my one, as long the thing you write here uses electricity, whether by battery or need to plug it to the wall socket. Yeah, they use electricity. So how will your life change if there is no electricity one day? So I think it's very drastic change, because in life we need to use a lot of electricity in everything we do. So again, there can be many answers for this. So maybe first, probably you cannot study, you cannot work at night, cannot study, you cannot work at night, because um before electricity was invented, before light bulb was invented, people actually couldn't work at night because they couldn't see. So if there is no electricity, there will be no light at night, can't work, can't study. Right. So number two, internet is powered by electricity also. So if there's no electricity, you can't go online. So you cannot go online, cannot surf the internet if there is no electricity. And of course there's no television programs. You can't watch television program. Right, so there are many effects of having no electricity. So anything that um is a problem when we don't have electricity, you can write them down. Okay, you don't have to follow mine. All right, so with that, let's go on to activity 5.1. All right, so electrical systems, what is the problem? Let's look at what we have learned. For a bulb to light up, let's say I want a bulb to light up, it has to be connected to the battery, because you need the energy source. Okay, and the switch. Okay, so parts of electric circuit, you have a battery, you have a switch, of course connected using wires to form an electric circuit. Okay, so for a bulb to light up, you need to connect using wires to the battery, to the switch, to form an electric circuit. All right, so we're not doing this, but I just give you the possible problems that you will face with a torch. So let's say the problem you realize is that the batteries are arranged wrongly. Okay, what I mean by arranged wrongly, for example, uh, let's say this is a battery. I have my positive and my positive together. Okay, and also for example my negative terminal and my negative terminal together. Okay, so basically you realize that if you put our batteries in a different way, if you put our batteries if you put our batteries that end I mean when you put the batteries together like this, for example, if you put the negative terminals together, if you put the positive terminals together, you realize the bulb cannot work, your appliances, electrical appliances cannot work. So for this, what can we do to make the torch work? If our batteries are arranged wrongly, what can we do to make the torch work? So simple. All we need to do is to arrange the batteries properly. And how do we arrange the batteries properly? Okay, let's write it down. Okay, what we mean by arrange the batteries properly. So for example, we'll put the plus and the positive and the negative terminals together. Right, so this is what we mean by putting the batteries properly, because if you put the same terminal together, it will not work. Okay, so you have to put the positive and the negative terminals together, like the one in the picture. Right. Okay, so if the batteries are arranged wrongly, all you need to do is to arrange the batteries properly, put the positive terminal and the negative terminal together, facing each other. So how does the action solve the problem? Okay, so when you put the batteries properly, the the electric the electric current can flow. Okay, the current can flow through the circuit. Okay, so this is what happens. The plus and the minus actually represent the direction in which the electric current flow. So why we have to connect a plus to a minus, because it flows through. If you connect a plus with a plus or a negative or a minus with a minus, actually the direction they are actually going against each other. Therefore, the electric current cannot flow. So when we put plus minus, like the diagram, like as indicated in the diagram, the electric can flow in a single direction. If we put plus minus and then minus plus, the minus minus will actually make the electric current flow in opposite direction, and therefore not allowing the electric current to flow. Right? So the next two are quite simple. If the bulb is damaged, if you want the torch to work, you have to replace it with a working bulb. Because if the bulb is damaged, you can't make it light up no matter how you change the circuit. The only way to do it is to replace it with a working bulb. Alright, so how does this help to solve the problem? Because if you replace a working bulb, then it becomes a closed circuit. And electricity can flow through, and electric current can flow through. Right. Right. So if the bulb is damaged, you just need to replace it with a working one. And once you replace it with a working one, then it becomes a closed circuit, because when it's damaged might be perhaps the filament blew, so there's a gap. So if you replace it with a working bulb, there's no gap, it becomes a closed circuit, electric current can flow through, and therefore it will work. Okay, last one, switch is loose. It sometimes because of wear and tear, the switch becomes loose. So same thing like the working bulb, you just need to replace it. Maybe not replace the switch, but tighten the switch. So sometimes you will tighten the switch, the connection is better. So when the connection is better, it becomes a closed circuit, and therefore um, electric current can flow. So it's the same explanation as the one on top. Right. Okay, so once again, if the switch is loose, all you need to do is to tighten the switch. So when you tighten the switch, once you close it, it will become a closed circuit, and then electric current can flow through. Okay, simple as that. The last two parts on reflection is quite simple. A torch is an electrical system made of different parts. Okay, the bulb, the wires, the switch, the batteries actually make up an electric system. So the torch made out of these parts is called electrical system. So in order for it to give off light, all the parts must be working properly, must be working together. And that's what we call it a system. So a torch is an electrical system. All the parts must work together to perform the function of producing light. Okay, so this is the homework for yesterday. I will be posting video to show you how electricity is generated, and today the lesson will be on open and closed circuit. Plus, I will be teaching you how to use the online software for the circuit construction. Okay, catch you later.